It is 6 o'clock, British summertime, and welcome to How to Repair Pendulum Clocks live stream. If there's anybody out there. So last week we had a bit of a dysfunctional week with our mainspring problems, but so hopefully this week we're on the more on the straight and narrow and a bit more organized. So in the past 15-20 minutes or something, I've actually just been spending time looking at this clock. Let's get that working. Focus, looking at this clock. And it's been a really pleasant kind of engagement, something that I don't know why, but I just don't seem to do that much. So that would be my first bit of advice, is when you're, particularly for a beginner and you're unfamiliar or reasonably unfamiliar as I am with the layout of this clock, then even though I've worked on hundreds and hundreds of clocks, not many like this. And as we saw last week, or not is the case, hi Franklin, we can run into difficulties with them. So I've just been thinking about where we want to go today. As always, our broad kind of direction is to sunny Dutch. Oh, it's sunny. We haven't got any sunshine here today. It's a bit grey, but it has been incredible, incredible weather. And so we broadly want to return the clock to working order, but that's not the point of these live streams. These live streams are to share the experience, basically, as not, I wouldn't say exactly an educational exercise, because it's not formalized in any way, but it's more of a sharing experience thing. So always great if people can join us. And it was quite nice last week because I didn't put the video up, or I did, and then I took it down again because it was a bit crazy on the health and safety front. And people said, oh, where's the video? So it was nice to know that people are still looking out there. So what I've done is I do have some commercially made clamps for my mainsprings, but despite my problems last week, I've actually made some more. I mean, these, I've just kind of thrown them together this afternoon. Very rough and ready. They are not a finished item, but I've got an idea about these clocks because I know that there are many ways of holding the spring so you can get it out safely, including zip ties. That was demonstrated by Jonas Troyer on our Facebook page, and straps. I was thinking of using this kind of strap that you find on an old-fashioned bicycle, because it's got a good strong buckle with it like that, and it's leather. So maybe something like that could do it. I don't know if that's strong enough. Or the metal clamps, the round section or flat section metal clamps. Anyway, at some point in the future, I'm going to get all these ideas together and do some kind of comparative test. Now, maybe that's already been done. So if you know of any such thing, then please let us know. Otherwise, we want to proceed and get the clock apart so we can test the bushing, test the depthing, sorry, and then during the week I'll clean it, and then next week we'll look at repairs. Now I've already identified, as is probably, just get a pointy stick, an issue on many of these clocks, and that is, we just zoom in here, there we go, is that the ratchet click here gets very worn. As you can see, both the rivet, the click, and the ratchet itself are all made out of brass, and there's a lot of force. They work at a really small radius. Now, of course, what would be better in terms of design would be if they worked at a larger radius. There would be less force on them and they would last a lot longer. But of course, these clocks are made, you know, to reduce the, hi Jeremy, reduce the amount of material. So we have to kind of respect that. However, what we can't afford is for there to be an accident with your client or somebody who's winding the clock because a mainspring releasing its energy, as we saw last week, instantly could actually break your finger or something. So this is going to be one of our main areas of repair. I don't know what I'm going to do about it. We've had a couple of suggestions from the internet, from our Facebook group. So let's look at that when we get it apart. The next thing, of course, is just cleaning, which is quite straightforward. I'm just going to use my normal paraffin method of washing, essentially. And then we're going to check to see if any bushing needs doing. And I don't know whether it will, but that's what we want to get to today. I want to get the clock apart and see if any bushing needs doing. So unlike last week, I'm going to use my health and safety gear, of course. Let's just zoom out a bit. So despite, so I've been making some sketches, which is really pleasant. As I said, it was nice, a nice 20 minutes. So despite there being hundreds of thousands, if not millions of these clocks around, you know, it still seems to be that the jury is out a bit in terms of letting the springs down. As I say, there are some very time-served methods, but the problem as I see it from the beginner, and I won't do it yet, but you have to somehow clamp the spring, either with a C-clamp or with some kind of device around it, like a bit of wire or a zip tie or something, which is fine. Then when you put the clock down, of course, in this case, there's the hammer, which is getting bent down, which is not very satisfactory. And the back of the clock, the movement, as you can see, isn't flat. It's got all the arbors and nuts and things sticking out. So it's never kind of, you know, I just don't like that. It just doesn't seem safe. The next thing, of course, is that you get your letdown key, and always do use a letdown key like this. There are a few types like it, and not the clock's own key for letting the thing down. And the reason for that is, despite how many times you do it, there's always that chance that the ratchet will slip and the key will spin round and it will hurt your fingers. So to avoid an accident, don't use the letdown key. I get a lot of people saying, if you can imagine this part of the letdown tool, Jeremy missed last week's fun. What happened, Jeremy, was I think I've chucked it in the bin now, but I made a homemade clamp which wasn't strong enough. It was one of my favorite materials, that Paxilin, sort of paper impregnated, resin impregnated paper, or the other way around anyway. And to make matters even worse, I didn't have my safety glasses on. So just don't do that. What not to do. So a lot of people say get a brush like handle, a dowel of wood like this, and put a slot in it. And if you can imagine this slot's deeper, you can hold the key. But again, you've got these bits sticking out, and that's still going to cause a problem. So I wouldn't use that at all. I personally, it's not worth it. Buy a set like this. There's a few different variations, so at least you can let the power down reasonably safely. Let's have a look. So you've got a problem because this is for beginners, and I know a lot of people are really experienced and they'll say it's fine, I've done thousands of these, but I'm really interested in getting yeah, Franklin has described it well. It was a total disaster. But this week, and there's not an excuse, but last week there was, you know, I really was kind of not in the mood for the clock thing at all for whatever reason. And normally I would just say, oh, forget it, I'll do it in the morning. But of course, you can't do that when you're live on air. So anyway, so the clock isn't flat. And then, of course, you have to hold the power off the spring. And of course, as soon as you do that, the movement wants to turn. So to me, I think what I'll do over the next few months or something is develop a kind of milled out piece of wood, because these mechanisms, these movements are standardized. So they're obviously different embouches or frame sizes. But once you've got one, but this clock, which is an Ingram 00, you never need to do it again. So I think something that clamps to the bench that you hold the movement in like this. Could use my favorite material, polymorph, or maybe something like that. Good idea, polymorph. Yeah, that's what I'll do it with. I'll have an experiment with that and make a kind of mold. So basically you can clamp that to the bench and then this is fixed and that frees up one hand. Okay, anyway, so let's get the power off this spring. I've done some brass lined pliers. I've done this side, but I'll double check. Yeah. It's always easy to forget. Right, okay, so here we go with my glasses and my gloves. But it's still a pain, particularly for a beginner, because I need a stronger bit of pegwood as well. So let's put our homemade clamp on. Stronger clamp this week. And I'm kind of, it might look like I'm being a bit awkward with these homemade. Oh, hi, Jonas. We're just talking about you. Your ears must have been burning and your excellent video on the zip ties thing. And so actually perfect timing. Oh, so the 00 is the date. Brilliant, because was it, I don't quite know where it is at the moment, but oh, here we are. I think it was Matthew Condon sent us this, which is a catalogue for this clock. It's called the Lancet, and it is dated, here we are, look, 1899. So thank you for that. That would make absolute sense. Oh, isn't that cool? Made at the millennium, turn of the millennium. That's really, really nice. Anyway, thank you for that. So yeah, on with our glasses. Oh, so you might think, well, why, Matthew, are you being super awkward and not going with either the zip tie method or the metal clamps, which I've got just across there? And the reason for that is because something in my brain is not wired up properly. And it always says there must be a better way of doing this. And I think it's not like a massive job to develop some kind of clamping system, I might be wrong, where you can just lay the movement in, fix it to the bench nice and firm, and it makes it not exactly 100% safe, because it's never going to be 100% safe. So for instance, if this plywood were, I've just done this today, so it's chucked together, but if this were one piece and this were all doweled onto a base plate, you could just fit that on, let the springs down, and anybody can do it without the panic. Anyway, that's my thinking. So I'm going to pursue that a bit. But in the meantime, hi, Ken. Good to see you. So, Jonas, if, sorry, I've not got the live chat. Team Open Clock Club still at work. So if that's the date stamp, do these movements, these Bosch, have like a Bosch numbers? Do they have like model numbers for the different sizes of frames and stuff like that? I guess they do. So I'm going to take the power on the spring, make sure my clamp is in place, and let the spring down. There we go. So you can see now I held the ratchet click out of the way. I suppose what I could have done is to have disengaged the spring tweezers. I could have disengaged the spring like this. The problem with that is then you're committed. The minute that you unhook the ratchet, it's not going to re-engage. But there again, I suppose the advantage of that is if it gets a bit out of control, it's not going to also damage itself. Anyway, so less drama this week, which is really, really cool. I'm not going to take my glasses off yet because I'm not 100%. sure about my homemade clamps. I think they're all right. So anyway, the point of tonight is really to talk about one of my very, very favorite subjects, and that's depthing and bushing. Brass line pliers, by the way, just in case you're wondering. So let's just have a look. So there we go. We've got both our springs clamped up. So I think if this piece of wood was one piece, it's obviously be much, much neater. And there were dowel holes in it, and that could fit onto a baseboard. Life would be super easy and repeatable, but maybe I'm wrong. I don't know. So I'm just going to triple check by undoing the other click. Now, I don't know whether the people who work on these clocks the whole time, and I know many of you have got more experience than me, do this as a way of checking, but to be absolutely sure that the power is off, I've just lifted the click out of the click spring out of the back of the click there. So we could check, but you can see no power on there. This side is tied up, so I can actually just take that off. No, can't be bothered to. There we go. So we have got no power on either train. That bit of wire will just consat. Good. So the next thing to do is to do some more photography. Now, I won't do that now. I'm actually just going to take some snaps with my phone, but you may or may not remember this device, which I use the whole time. It's absolutely invaluable in my practice, kind of my like day job, because obviously dealing with not loads of clocks, but maybe 2 or 3 a week that I process. It's so easy to forget. You think, oh, I won't forget, but of course you do forget. Folded it in the wrong place. So these photographic scales are a dead easy way of just making a note, stick that in the photograph. I know I've mentioned this before, but it's incredibly useful just for remembering, okay, that was that clock. And it gives you a great record as well, particularly when you, just get my phone started, particularly when you take clocks in on trust. If you're running a business, you might be in a situation where, I don't know, somebody drops a clock off, or you go to somebody's house and you pick it up and you dealt with all the estimate. It's really useful to make a photographic record of, I don't know, I know Jeremy deals a lot with the public and all that kind of stuff. Whether you've ever had this problem, I had this problem once and it was so unpleasant. I mean, it wasn't really, really bad, but it was unpleasant enough to vow that it would never happen again, or I'll try and avoid it happening. And that's basically a client, for whatever reason, they misremembered, or who knows, somebody could do it maliciously, but they say it wasn't like that when I picked it up, or you picked it up, and it's been damaged or something. I did read a story in one of the journals where, as well, and this is sort of the other side of that coin, okay, thanks, Jonas, for that info about the different manufacturers. The other side of that coin is somebody who took a clock in for a repair, and there wasn't a kind of formalized contract or treatment proposal of what you're going to do. And their practice was that they polished up the case, French polished or whatever. And for whatever reason, the customer didn't want that doing. So there was a whole hoo-ha about it. So anyway, it's really incredibly useful to use these things. They're on my website. They're free to download if you want to download them and print them off. Do what you will with them. Right, okay. So we've taken some photographs. I made some notes in my book. We took off the regulating, the patent regulator. We took off the deadbeat pallets. That's another repair that I know we need to look at, because a lot of the escape wheel teeth are quite short. And also this front escape wheel pivot is a little bit worn there, although I'm not convinced that that needs rebushing, but we'll deal with that as we get down the line. So we've got these bits of brass wire. So again, I would say, you know, what do we do with these? Do we reuse these? Are they a consumable? Or do we try and preserve, do we try and preserve them? Oh, hi, Jim. Thank you for joining us. Now, these two down the bottom, the one that relates to the bell, the passing striking that we talked about last week, and the one that relates on this side of the movement to the cathedral gong. Now, they're still quite neat. So as much as that brass wire is probably work hardened from the off and will only be work hardening with time, I think we can probably just ease them off like that. Oh, that one's crazy long. Yeah, I mean, I think it's probably quite difficult to extract these neatly. So there's a question. I don't know what, oh, one of our notes is undone. Remember, the pitch will start working on this, give receipts, test whether the key pens and ways. Absolutely, Jeremy. 100%. Take photographs. Photographs are dead easy with your mobile phone, and give a receipt that states what you've got. And importantly, I always say as well, what you don't have, because winding keys are obviously the classic thing. Case keys are another one. I took a little fusee dial clock in the other day with 2 case keys. But if the case keys are not there, I always put that they're not there as well. It takes 3 minutes to do that, and it can save you such a lot of hassle as well. Okay, I think we've disconnected those two. Let's just disconnect up here as well. So we've got the mobile here, the lever for, camera might not focus that close. It's a bit, asking a bit much of it. And you can see these 2 wires are not as neat as the ones on the bottom. They're more like a rat's nest. So I'm going to disconnect them. That's for the lifting piece. And this one is for the count wheel detent, that arbor there. So they're both disconnected now. I'm going to not commit to whether I replace those or not. I'm not quite sure. If they do the job, you know, if they fail and they're a bit kinked or a bit work hardened, it's kind of not the end of the world. You know, what's the worst that's going to happen? Anyway, so triple check that our springs are contained. And I think that these nuts are 1/4 inch across flats. And you might remember many moons ago that we made some spanners and gave some away on the live stream, because the Smith's Enfield clock has also got 1/4 inch across flats nuts. So let's have a look. Yep. Now, there's always that question, and the good thing about using this, of course, or you could use a 1/4 inch socket with a bit of tissue paper. You know, if you get, if you get a bit of tissue paper like this, and you've got a 1/4 inch socket, you know, just like a car repair socket, at least it's kind of gripping the nut in more than one place. Put your bit of tissue paper on like that, and put the spanner over it. And that just prevents the plate from getting scratched. So these nuts, looking at them, I think some of them are on inside out. Finding my way, we're learning together on this project. Let's just slacken all these nuts off. So that little 1/4 inch spanner that I thought I was never going to use again, this was actually one that my son made, which is quite sweet. Is incredibly useful. So not only does it fit American clocks, but it also fits the Smith's Enfield. So really useful thing. So we slackened all the nuts, but these components are stamped out, I think. And it looks like the nut has got, let me just look through my eyeglass. Yeah, it does appear that the nuts have got one slightly curved side and one flat side. And I would normally say that the flat side goes towards the frame, but of course it's going to damage the plate. And I think that like that one there, for instance, is what I think is the right way out. It doesn't make a massive amount of difference, but it's just nice to kind of observe these things. Because as Jonas said, these little, oh, hi Ian, just back from his holidays. Thanks for joining us. These little differences, these tiny differences, in fact, are really worth noting. That's the way that you build up a kind of knowledge of the clock. So I've got my tray here and nowhere really to put it. Let's have a bit of a rearrange of things to put all these parts in. There we go. So normally I use plastic tray, but today I'm using a cardboard tray with paper lining. These, do I have one here? Oh, here they are. These are also really, really, really useful. They are so-called disposable paper trays. And the reason I like these is you can vacuum them out when you're finished and you don't have to chuck them away. But of course, when you do decide to throw them away, they're compostable. So I got those from a catering shop. There's a industrial kind of kitchen shop just down the road here, and they're incredibly inexpensive. So if you're always looking around for trays to keep things in, the beauty of the paper, of course, is it doesn't scratch and mark the parts, unlike using metal. So I'm a big fan of those. Right. Slightly nervously about taking the lid off, given that the springs have already tried to kill me once. Let's just have a look here. So we've checked and checked again that the power is off, and we're just going to lift off the back plate. So gently does it, and see if we can lift that away. Okay, brilliant. I think I did ask before whether these plates are nickel plated on brass, and I think the answer is they're steel with brass bushings. If you're on our Facebook group, and as always, massive thank you to people who contribute to the Facebook group. Sam posted this week a Swedish clock. He's on holiday in Sweden. Everybody's on holiday, apart from me. My life is a permanent holiday though, so I don't mind. And that clock also has got iron plates, Swedish iron, with brass bushings in it. So it's really interesting to think about those immigration and emigration, the people maybe in Europe who were making those clocks and went to America and said, well, we don't have much brass, but we've got a bit of steel or iron, you know, how can we do this thing? No doubt the that wasn't intended. Did eat too many pasties. I'll Cornish pasties. So anyway, but what I notice here, look, you can see is that the plate appears to be gilded, or something is going on there and there. As much as it's kind of been scrubbed quite a bit, I wonder whether they were electroplated to make them look like brass. Again, I don't know enough about these things, but yeah, pretty sure it was. Look there as well. Can you see that reflecting in the light? Yeah, just zoom right in there. So it does appear that when new, they were either electroplated or they were lacquered. I'll just have a little look. Yeah, you really need to look under a microscope, but it appears to be lacquered. Yeah, it's lacquered, I think. You can see the brush marks here, sort of drips where the stuff's a bit thicker. So getting back on my so-called conservation soapbox, there's another good reason not to put the thing in the ultrasonic or to use ammoniated solution, because you are likely to lose the rest of that lacquer. We'll probably lose some anyway, because the thing needs a bit of a scrub. But there's a nice bit of evidence of manufacture. And, we always like to, well, I always like to think and talk about what things are. This is Team Open Clock Club's favorite sort of conversation is, it's a clock and it's to tell the time. But beyond that, the kind of social function, the industrial sort of history of industry function of these things is tied up in those tiny bits of evidence. Hi, great. Our lunch break in Illinois. Really glad that you can join us. We don't have any feedback on the live chat, I'm afraid, because our normal support team is at real work, not doing this stuff. So just going to take this opportunity to take a few more snaps of how clocks work. So what's the weather like in Illinois? There we go. So just taking a few more snaps there. Not taking any chance with these clamps. I hope they are meaty enough. I'm still thinking maybe I should have my safety glasses on, but I think the springs are in there for the time being. So what I want to do now is to lift away these levers, and so I can get to the mobiles, because by the end of today, I want to have gone through the depth thing. This is the key thing. Oh no, poor old Jane's got car problems. Dear me. So let's just lift these. Oh gosh, I'm in the incredibly fortunate position of not having car problems now, because I don't have a car. One of the great joys of living in a city. So what I'd normally do is to photograph these components. This is kind of new territory to me. It's been a long time since I looked at these objects. So what I'd do is I would photograph each piece for the first time, at least, together with my photographic scale, just as a little aid memoir. But the condition of this thing looks really good. In fact, if you look under here at this, so this piece is the lifting piece, isn't it? We've got we've got lifting here. Sorry, put it where you can see it. Let's move that out of the way a bit. So we've got an arbor with 3 functions. And I suppose when you think about the people who designed and made these clocks here out of wire, like super clever and efficient design, you think we've got a thing here that's got 3 functions. And then we look now at microprocessors, and they've got however many, 3 million functions or something. So yeah, a lot of change there. Look at the condition of this. It's incredibly rust-free. So again, lots of evidence there of manufacturing processes. So just to get this right, we've got the lifting piece here. So this is resting on that thing on the center arbor. We've got warning here. And then we've got this piece lifts the count wheel detent up. So quite useful to be able to identify those 3 functions. And then we've got this bit of brass wire as a return spring, which, as I said, Jane, you're just working on, it's not an American clock, is it? It's quite nice today that it was identified on Facebook. It's a Japanese movement in a Japanese case with an American dial. It's a Franken clock, as you call it. But what are the springs like? What are those little wire springs like on your clock is what I want to know. That's nice. 72 degrees. Oh, across 72. Is that right? Okay, not 72 degrees. Great. We'll love our weather reports. Well, as I said before, York it's been amazing for the time of year, but today's been a bit cloudy, but it's warm. It's incredibly warm. So what is next to be removed? Maybe we can, no, we can't get that out yet. So let's start with our warning wheel. And last week, although of course you didn't see the recording, we talked about the phase relationship between the different wheels and the striking work, which is really one thing looking at the Facebook group is that is the one thing that catches people out. So we decided, I'm sure you already knew, and I made it up as I went along, that this clock is really easy to set up in terms of the phase relationship of the striking train, because the count wheel, which is down here, is indexed rather than being directly driven from the train. So it moves on in discrete lumps. The lifting pin here and stop wheel, so it's got a triple function of passing, striking, lifting, and stop wheel is all in one wheel. So you can't possibly get that out of phase. So the only thing we have to think about when we reassemble the striking train is this chap here, which is the warning wheel. And we have to make sure there's a reasonable amount of run to warning. Okay, so let's just lift out our fly. Now with the fly, again, I think somebody on the Facebook group just posted a picture of a fly from a American style clock with some big lumps of something. I don't know whether they were chewing gum or whether they were lead, but hey, Team Up Clock Club's turned up. Great. Can have a sensible conversation now. Well, instead of listening to me the whole time. Oh, nice. Jin's got a lot of interesting things to do in Bristol, but she's not going because the car's broken down. Yeah, we used to live, sorry, boring story coming up. Time for a comfort break. By the river, overlooking the river. We didn't call it the bore, we called it the Eiger, was it? Or the something like that, where you get this unusual tide where the river rises really rapidly, sort of. You could hear it coming, sort of, would rise a foot or 2 feet or something really exciting. No surfers on ours, I'm afraid, up on the Yorkshire Ooze, just something nice. So the fly, quick point here, really important that the fly is able to move on its arbor. And you can see here, it's just a really simple kind of friction arrangement between the two components. If this is solid, and you sometimes see them soldered up, what that leads to, but this can be a lot looser, I think it will be looser when it's cleaned a bit, is a lot of wear on the striking wheel trains at the position the train locks. Because what the fly does when it can move around is dissipate energy. This is too tight, I think. It needs to be looser than that. And maybe also allow the train to start a bit quicker, but I'm not convinced by that. So let's just get that out there. There we go. So we've got our fly. So people, this is something we've talked about before quite a lot, and that's, you know, where do I progress with my practice? What do I work on next? And these clocks, of course, are great because they're plentiful and they're relatively inexpensive, relatively. But as I say, I see the big problem with them, particularly after last week's episode of these springs, because as a beginner, it just seems like really making life difficult for yourself. But anyway, so let's just pop out our warning wheel like that. Again, all looks in good condition. Don't know whether you can see here. Let's see if we can get the camera to focus. Yeah, just about. Yeah, there we are. Is that the pivot is not parallel, and I totally don't care about that. In a clock like this, really doesn't matter. Totally leave that as it is, unless the pivot is completely worn away. Yeah, it's a tiny bit mushroomed, but there's absolutely, in my view, no issue there with leaving it. Obviously, it needs cleaning, but no pivot polishing or refinishing. And we'll talk again about that a bit later on, why I say that. So next out is our multifunction lifting stop wheel thing, but it's got another function, hasn't it? Because it also indexes the count wheel here. So this is incredibly clever. Whoever designed this clock needs a big pat on the back, or a blue plaque, or whatever the plywood. If you like plywood, there was I didn't see it, unfortunately, really kicked myself. There was an exhibition at the V&A, the Victorian Albert, 3 or 4 years ago on plywood. really cool material. Anyway, so yeah, this is super clever because in terms of assembly or reassembly, you don't have to worry about the relationship between these functions because they're fixed. So how cool is that? Pinion leaf wear on this is actually low. I mean, it's maybe 10%, something like that. Yeah, there's a bit of pivot wear. So good condition, happy with that. So far, so good. Can we lift out this cant wheel deadened? So what we've got here, this is the element that is lifted by the other piece we just saw, pushed up underneath there. This little hook is the stop hook. And then this, of course, is our cant wheel detent itself. I'm not sure. Maybe I do know why. What that's for. I saw this picture today and I kind of remember it's for putting another piece of wire through. The cant wheel striking clock, of course, the beauty or problem with cant wheel striking is it's a sequential system. So it strikes 1, followed by 2, followed by 3. You can't do anything about that, unlike rack striking. So if the hands and the striking disagree, they get out of sync. You need to synchronize them. So what you do is, I think that's what that loop's for. Anybody know? You put a bit of wire through there or a little thread or something going up from the top, and it means you can lift the detent in order to synchronize the striking and what the hands say.
Matthew Jeremy says, is the pinion damaged too?
No, it's worn a bit, about 10% maybe, but no, it's so far in good condition, whatever that means. So let's lift out. So I don't know what the names of these wheels are. There's high drama in certain circles, no names mentioned, about what things are called. I don't care what they're called. Pretty relaxed about it, other than, of course, it helps communicate if you have the same name for the same thing. Again, this is one of our conversations that we have the whole time is, the name of things and how that changes. So just zoom out a little bit.
Jeremy meant the warning shell pinion, the first one that you took out.
No, it's just dirt. Focus, 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 focus. No, don't think so. I mean, that's interesting point. I'll try and remember to share it with you, although it's a little bit tricky because I don't have permission to share it. But I saw a clock the week before last where the fly pinions were like so worn, where the pitch circle diameter had reduced significantly, and it was just kind of rattling about. Not a bad thing. I think people get too excited about it. However, there is, and we'll get onto our depth thing in a little bit when I've got all the mobiles out, there is a different, obviously, geometry with a lantern pinion like this from a regular sort of ogival pinion. Yeah, it's too big.
Ken says his OG clock.
Yeah.
Same way with the wire in the loop.
Yeah, and is that what it's for, Ken? That little wire it's so you can put a thread in there or a piece of wire and push up the detent. I guess that's what it is. I can't see from a manufacturing perspective any other reason why you would make this extra complication here. I'm pretty sure that's what it's for, but I only remembered that because I saw it on Facebook today. So we've got 3 wheels here in our going train, and let's just zoom in a bit. So we've got our great wheel here, which we can ignore, and we've got our escape wheel here. Well, we know the name of those, great wheel and escape wheel. So we've got 3 intermediate wheels, and if I have it right, which I may not, they don't have any function other than they are gearing, basically. That's all they do. They basically gear up between the great wheel, which rotates relatively slowly, and the escape wheel that rotates relatively quickly. And of course, as a direct proportion of that gear ratio, there's a reduction in torque. Oh yeah, definitely the gas problem. I know we've all just, good job, we just bought our gas bottles with the price quadrupling. Yeah, think of all those test stands. They're going to be in massive demand now. There's a panic on for heating. I'll be able to sell them at a massive profit for all the wood burning stoves that are around here. So we've got 3 intermediate wheels. So what do we call them? Well, in a watch, you would call it great, which is the barrel typically, second, third, and fourth. So that's fine. My point is that there's no hard and fast way. We could call it upper intermediate, lower intermediate, and intermediate, but that would be a bit daft. So let's just hook these out and have a quick look. Right, okay. Well, this, interesting.
Ken said it is a wire to push up, but he's only ever seen it on a couple of clocks.
Right, okay. Thank you, Ken. Yeah, it makes sense. So here's a pivot that is, I don't know if you can see that. The camera decides to focus. Pretty worn. It's probably down to half its diameter. So of course it's a relatively thin plate. So you've got this enormous bit of pivot that's sticking out and doing nothing. Then you've got a tiny bit of pivot here that is wasted. I won't go off and find my caliper. This is a thing for Facebook. And I know what people are going to say. They're going to say, you've got to replace that. You know, the world's going to come to an end. Something's going to explode and it's going to go off its axis if you don't replace that. I'm not convinced, entirely convinced. The reason that it's worn like that is because, well, it's a material, obviously bearing surface, but it's the fact that the clock has been running dirty. The oil's been contaminated, causing accelerated wear. I wonder, my interest is in the depthing that this makes. I'm not bothered about that wheel snapping off. It's taken an amount of years to get to that point. However, I'm going to be in the minority there. People are going to pull their hair out and say, you've got to. There's no got to, should, must, have to. And I wonder whether if we could do some bushing there and just put an extended bush on the outside that uses up some of this unused pivot. Anyway, that's a question, and that will cause an enormous amount of controversy. But I've kind of, well, I would like to say I'm someone who's never shied away from controversy, but actually that's not true. I have particularly like it. So here's our intermediate wheel, which, can we get that out? Yep, just about. And the same thing there. We've got another pivot that's down to about half its diameter in terms of wear, and another one there. There is no way on this earth that I'm going to repivot this whole clock. It's not that it's not worth it, but I just don't want to do that kind of intervention. I've got a feeling the clock will run absolutely fine. Obviously, there is a point where it wears right through, and then one day the clock goes like this, and yeah, it might cause some more damage. I think, yeah, it might do, I suppose, if it's on the pinion end, and we don't want that to happen. But I think about extended bushes. That's kind of where my mind's going. We've always got options, remember. There isn't only one way to do things. Right, well, I've got no idea what's going on here with that little chap there. That is part of the motion work, isn't it? So on the clocks I'm used to, the motion work's on the outside of the frame. It's under dial work. In fact, I'm just going to get my camera out and take another photograph because I'll forget where that goes. Not that that's insurmountable, but it'll save me a headache in future. Yeah, so, and also with those warm pivots, the kind of other obvious thing is, what can we fill them with? You know, the pinion's fine. They've got this enormous length of good pivot that's never, ever been worn. And then we've got this small wasted area. Can we actually fill that? I mean, we've talked about laser welding, that kind of thing. Is there some kind of metal glue that we can use to build up those pivots again? I don't know, but let's think about it. So there's our motion work. Don't know what the ratio is, but we can do a train count that goes in that tray. Here's our intermediate wheel. Is that gonna liberate it? Yeah, there we are. Oh, and the same thing. We've got a pivot here. I just wiped it off with my thumb. That's got wet oil on it. And we've got a pivot here that's failed, where the lubrication's failed. It makes such a massive difference if the clock has been running either dry or without any lubrication. Yeah, I'm not going to drill out all these arbors. That ain't going to happen.
Ian says wearing of the lantern pinions is often a bigger problem.
Yeah.
If it's danger.
Yeah, I mean, I suppose if they wear through, they do eventually collapse, and then you've got that sort of exploding spring scenario. But, you know, it's a good question because they're not impossible to replace. You can open up the trundles and replace them with new wire. But it's not that it's not worth it. I mean, that's a useful thing to do, I suppose, if the lantern pinions are particularly worn. Right, I'm not sure we can get that out. So let's just lift out our center wheel arrangement. And so what we've got here is a really cool safety piece that allows you, I think that's what this is for, it allows you to turn the hands backwards. So this part of this spring is a lifting piece for the passing striking. So must be the lifting piece as well for the regular striking. So in one direction, the thing just spins around and spins around and spins around like that and doesn't do anything. And in the other direction, the back end of this spring here touches on a little pin that's driven into the arbor, meaning that it comes to a stop. Super clever arrangement. A bit like if you ever take one of those main synchronous Smith's clocks, they have a similar thing sometimes that reverses the direction of travel of the rotor. And here we've got friction work, a little bit like the Smith's Enfield. We've got a compressed spring basically that is the friction. You can see here, I'm holding the arbor still, but I can move the train. But it would be the other way around. The train would be static and you can move the arbor because that's got the minute hand on. So this is the clutch here for people who haven't seen these clocks before. Presumably this wheel is driven on and driven onto this arbor, and then this pin may or may not be intended to be removed. I don't know. We'll find out when we get it cleaned up a little bit. Then we've got a little wire circlip thing here, which is holding another spring there, which keeps this one pressed against that stop. So really clever engineering, nice quality, nicely made. And then we've got a very long cannon wheel that fits on there. So all good, all good. Next, and we've got this circlip arrangement here. Is that going to come out? Maybe not. Maybe got to get the barrels out, the main springs out first. So let's lift off our passing striking that we've just seen. Pretty straightforward there. Again, in the design, they've used a spring, not as a spring per se, but to actually make what in other work might be a pipe or a collet or a tube that's riveted at both ends. So basically taken three components and made them into one and made it relatively easy to manufacture. And here's our brass return spring thing. So I'll photograph all these parts and try and get my son to put them on Instagram. Let's lift out this escape wheel, which I know is damaged. Again, pivots. Ooh, yeah, same thing. If you can see that there, front pivot, pretty mushroomed. Yeah, I mean, this clock is going to be fine as it is. We'll figure a way around it. I'm not going to repivot it all. But I do know that a lot of these escape wheel teeth are damaged. They've got the tops missing, presumably because somebody's moved the pallets out of the way when it's been wound. It's spun round and they've jammed the pallets back in there. So that's a bit of a shame because it's going to mean that without making a new wheel, and maybe you can just buy these wheels. I know there are a lot of these clocks made. But anyway, so that's our deadbeat escape wheel. And also here's a question that I should have asked myself before, and that is, are these great wheels and springs interchangeable? Now they obviously wind opposite directions, as we said before. They wind into the center. So the going train winds counterclockwise as you're looking from the front, and the striking train winds clockwise as you're looking from the front. So in that respect, they're not. But my point is, could you accidentally assemble it the wrong way around and then have to take it to bits again? They do look, I would imagine they're the same stamping, and I imagine the springs are the same, but I don't want to get the springs mixed up. So I will actually mark them. In fact, I'll do that now. I'm not going to mark the springs, of course, but I'll just put on here. On my nice homemade clamps, which so far I've not tried to maim me, so I'm warming up to them. And also, of course, they're kind of very broadly a nice heart shape, so they I'm getting to love them quite a lot. Right, so let's just work this one off the pillar. Can. It's all sticky, yucky oil in there. Okay, so there's our going train. Great wheel. Presumably this ratchet is all pressed onto here. I don't suppose it's soldered on, but again, if anybody knows, please let me know. I imagine it's just a really good press fit, but I don't want to get that apart if I can. But there's going to be an issue here with this click. Just put that back in there, because as you may or may not be able to see, the click is already, well, not already, but it's riding up so significantly that I can imagine it could drop out of engagement, which of course would be bad news. So what do we do there? I can see that the ratchet wheel teeth have not worn evenly, so they've kind of started sloping over. So one thing you could do, I suppose, because these wind in opposite directions, if you could get them off, you could swap them round. You can't swap it round on its own arbor because the teeth will be pointing in the wrong direction. But you can certainly, I've lost my little picture here. You can certainly swap them side by side, I guess, in theory at least. But obviously you can only do that once, and so on and so forth. So yeah, there's a question. Are these collets driven on, or are they soldered on? Don't know. So let's just see if we can get our arbor out of the spring center. That's the key. Get it to unhook, which is a little bit. Now you would like to think that you can just wind the thing anti-clockwise and it would come unhooked. Maybe that's not the case. Okay, right. You can't just wind it anti-clockwise. So I should know this stuff. As I say, we're on a journey together on this, because it's not a snailed hooking, or it's not a curved on the back, so you can't just unhook it. You actually have to hook it off. So there we go. I've learned yet another thing. So there's our go inside mainspring. We'll deal with that next week. But yeah, so far clamp seems to be holding up. So good. Glad I saved that bit of firewood. Just look at this. Cool. Yeah, the pivots here, strangely, are really like, I mean, they're worn, but even on this front pivot here, you can still see the turning marks from when the thing was made. So you can imagine the this thing coming off the lathe, which is really nice. But yeah, this click, or both clicks in fact need attended. So that's going side. Let's just go back to our block. And this is striking side. Getting the hang of this now. He says pride comes before a fall, of course. So now I know that this doesn't unhook. So I'll just get it in the middle of its travel, about there, and hold that and just hook it off. Good old brass tweezers. Use them the whole time. Maybe there's a more elegant way of doing this. I haven't discovered it yet. Let's just see if I can figure out where the... Presumably once you've done a few, you can actually figure out where the hooking is. Can't see it, it's all a bit dark and yucky in there. Because I don't think there's any chance of the spring coming out of the holder, but I can put them on. It's a good point, Franklin. After last week's event, anything can happen. Thank you for reminding me. This, it says, again, pride comes before a fall, but the beauty, and maybe it will come to bite me later when I try and get the spring out, the beauty of this plywood is it's really grippy. You know, with the steel ones, they can slip, but not with this. It's really got a good grip on it. Because all I have to do is to be able to figure out how to get the hooking off. Feels like it's getting there. Show you when you've done 20 of these, you can do it straight away. It's like disgorging a fish, isn't it? If you know what you're doing, you can just right. Yeah, I'm going to just open it up a little bit. So what I thought was a so-called never such a thing as a kind of easy repair, is that there's always something that not getting the arbor out, I'm talking about those pivots. There's always something where you think, right, okay, what are we going to do there? How are we going to make this work, make it safe, and so on.
Said if you push the arbor out, you can also push a spring coil out.
Exactly, you could, which is why I don't want to, by the way, thank you, Franklin. Why I don't want to push it too much, because I don't want the whole thing going like that. But good point about the glasses. So there we go. That was my Keanu Reeves moment, believe it or not. Team Up and Club probably didn't. Is that an acceptable thing to say?
I think so, but I don't know what it means.
All right, okay. I saw there was, you know how YouTube, if you're on YouTube, it suggests videos, and I occasionally, well, every day I watch a video about the Nürburgring, just one YouTuber. I've got down to just one, watch that, but it suggests a lot of car videos. And there was this film, and it was Keanu Reeves, who is an actor, I think, and something was happening. I had the sound turned off, but he was riding a Norton motorbike, and all the press was stood around, and it's been a bit of a faff. And of course, when he came to start it, those old English bikes, absolute pain to get started, because kickstarter, no electric start. And he kicks it a few times, once, twice, and you think, if that were me, I would just walk away and get an electric start, get a Honda. But the thing is, he just keeps going. And after a few minutes, he gets it started, and then he's off. And I thought, that is so cool. And with situations like this, don't give up, just keep going and be calm and you'll get there. There we go. So both springs liberated, and we've got both our great wheels to remember which is which, although I think I saw on one of them. Maybe oh yeah, I did see on one of them. Yeah, another boring story, but you don't obviously, I go on about this, need to mark anything. You know, we're making enough mess or marks or change or intervention already by just taking it apart and putting it back together. This wheel, as we've already identified, I can't remember what it said that they wind to the middle. Was it Jeremy a few weeks ago? That you don't need to mark it. You know, the other one, wherever it is, the Go train, is completely different. They cannot actually be interchanged in the clock works. Yet this one's had scratched on it 3 times, S. I don't know what that stands for. Answers on a postcard, please. Yeah, once, twice, 3 times. Twice it looks in the same hand, and then a 3rd time in a different hand. And I wonder why they've done it like that. You won't be able to see here, but I'll try to take a photograph of it later. But it's, here's one. Let's try get it in some reflected light. It's an S, but a bit like a $sign. I don't know what a $sign's like, but with a kind of strike through. And you would think that was a mistake or something. But if you look here, exactly the same. This kind of S with a strike through. And then here, which is a different person, totally different hand, another S with a strike through. So what does that mean? What does that thing? Because S would be fine. You don't need that additional mark on there. Anyway, don't need to mark it at all. And here, let's just see if there's any.
Jonas said he was hoping for an easier way to remove the mainspring from the arbor, but it looks like it can be difficult even for the experts. Smiley face.
That's really sweet, Jonas. I am not an expert on these clocks, but I'm hell-bent on practicing and learning more about them. Yeah, I think with that, you can make a tool, can't you? I think what I would do if I did more of these clocks, or maybe even this, is just to make a tapered, drill a bit of brass, turn it to a taper, cut a little piece away, and then you can just shove it in the middle of the spring and it'll push the arbor, push the spring off the hooking. Might try that. Anyway, that's yet another job to do. So this one's got G on it for going. Sometimes they have W on for watch. And it's got that, again, 3 times, I think. 1, 2, yeah, 3. Yeah, so it looks like, again, the 2 Gs there and there are from the same hand. So it looks like this clock's been back to the same person twice, and then another person's had a go at it here. And interestingly, they scribe the, scratch the letter where the crossing is, which is, you know, it's all part of the clock's history, but I wouldn't do it anymore. Great. So going done. What have we got here? I need another photograph. All getting a bit yucky with the oil. Little snappet there. Good. And can we lift this chap out? Just get the spring. So there's our cathedral gong hammer assembly. Now with my patented plywood mainspring holding device, safety devices, I did have to bend this arbor out of the way, which was one element of it that I need to think about, because obviously that could either loosen it or shear it off. So I need to give that some thought. So we've got the hammer lifting piece here, obviously the hammer shank and hammer head, which had a bit of leather in it, still got a bit of leather, it's got worn right down, so I might replace that. And then the stop here and the return spring, so all good there. And, yeah.
Sorry, Matthew. Do you want us to put a notch in the middle of that tool, kind of like you do for taper pin removal pliers?
Yeah, yeah. So you can just push it in, and then it would just be a one-stop shop. To maybe Jonas wants to make a video about making that tool. So what we're going to do, get a bit of brass, drill a hole or a bit of brass tube that is, just have a look for a bit. Sorry. Love a distraction. So get a bit of brass tube like this. But this would do. It's a bit sloppy, and then file a notch in there, and then taper the end. So you can just yeah. This wants to be a really good fit on the arbor. This is too sloppy, but I could probably close this up if I filed a slot in it. And then all you have to do, you can even do it with your eyes closed, is push the thing in, rotate it till that goes in there, push that down. And if the wall of the tube is the same thickness as the little arbor hooking, the spring will just come out. There you go. There's a good challenge for somebody to do that thing. So what have we got now? We've got our count wheel, which is the second wheel in the train here. I've lost count already. There we go. That's that. And I'm going to get that mixed up with a train wheel because it looks very much like here's our lower intermediate wheel from the going train. And you can see they're incredibly similar. I mustn't actually take my hand off. In fact, what I'm going to do, I'll put that back in there. It was that way around, wasn't it? Those two fit together, is to get a label. I took the labels off to thingy, didn't I? Bit of chaos, I'm afraid, because I took my labels off on site work and I've not put them back where they belong. So anyway, let's just put a bit of cotton tape on instead. Chunky tape. Now it might be that that there are differences. So let's just have another look. Sorry again, if somebody knows the difference here. Are they the same? Yeah, they look to be the same wheel count. I think they are. And in terms of arbor length, yeah, let's do that, turn it around, do that. So unless I'm mistaken, they are essentially, when the clock's been made, I'm making this up as I go along, obviously, because I've never seen this for at least 20 years anyway, that again, incredibly cleverly, in terms of the design, they've kept life simple by making the lower intermediate wheel the second wheel on the going train, and then this count wheel, second wheel in the striking train, the same wheel. But I don't want to get them mixed up, obviously, because the holes have worn accordingly. So I'll find my labels. Just interesting to see if anybody's scratched on them. Oh, they have. Okay. So that's kind of quite nice because it makes my life easier. Yeah, oh, something on there, but I don't think it's. Yeah, so somebody scratched on that one S for striking, but not G on the other one. So even if my label falls off, then at least we know which is which. Okay, so let's put that in there and that in there. And all we've got left is our little cant wheel with a friction spring holding it on. So that's super sweet, quite stiff to turn this. So again, make sure that that spring, like the springs in the back of our great wheels on long case clocks and things, is not tight. You know, all it has to do is to stop it from vibrating round. Do remember though that with this, you've got the hammer hitting that gong and the whole clock's going to be going gong. So if that can vibrate around, it will vibrate around, but it certainly doesn't need to be tight. I think this is only tight because it's got old oil on it, but you don't need to go tightening the thing up. So presumably there's a tab in there. Yep, I think so. That we can push out, he says. Yeah, it's quite tight. Right, yeah. Also, somebody has scratched on the back of this wheel here, look, B for back, so they don't put it on the wrong way around, inside out. Just going to get a scalpel to lift that tab. I guess a lot of these get cleaned, I don't know, without taking that off. They just leave it on because it's a bit of a pain to get it out. There are scratch marks on it, so it's been disassembled in the past.
Derek's just joined us.
Oh, hi, Derek.
He's just been to his funeral.
Oh, dear.
Special shout out.
Oh, special shout out for Derek, who's had a bit of a tough day, who's one of our stalwart Facebookers and so on. So, yeah, we're thinking of you, Derek, today. So very, very, very big thanks for joining us for the last 10 minutes or so. Unlike last week, Derek, you haven't missed anything exciting this week, as in no near-death accidents, and we haven't had to go down the emergency room. Although I have just bent the end of my tweezers. So, oh, no, I can't get it back together again. All that excitement. There we go. So rather than pushing this little tab from the back, which is uncontrolled, just get your scalpel. I'm making this up as I go along, but I've learned this now, and you can just pop it off. Easy as easy. Don't lose that. Striking train. Okay. And then this cant wheel lifts off. All good. Just check there isn't a washer there. Sometimes you get a washer between these components, but not in this case and not on these clocks. So I think we're about there, aren't we? We've done our disassembly. This chap is bent over on the inside, so we can't get that off. That's riveted on, that's riveted on. Yeah, that's it. We've done our disassembly. So thank you for bearing with me. So for the next 10 minutes, what I'm going to do is to go through, and I know I'm repeating myself many, many times, but on the basis that there's probably somebody new and new people are joining the whole time and people looking at the video. If you're repairing clocks, you will hear about this thing about bushing. And so, yeah, I know it's time for a comfort break or a snooze. Those people have heard this 4 million times already this week. Bushing is the act or the process of replacing bearings in clocks to change the center distance between mobiles wheels to improve the quality or the efficiency of the mesh of those gears. Bushing is not to take out the slop in the bearings. The slop in the bearings, either caused by manufacture or by wear, is an indication that bushing might need doing, but it doesn't indicate that bushing doesn't need doing. What you need to do is to check depthing first. So that's what I'm going to do. And I'm going to make a note of what I need to depth. So how we do that is get our first pair of wheels. Now, this is going to be a bit of a laugh because I can't even remember how the thing goes back together, but that must go in there and that must go in there like that. Right. So reassemble the frame right way out. With two mobiles in, it doesn't matter where you start, but it kind of makes logic to start at one end of the train. There we go. Let's get that on. No, sorry. I was right first time. Just getting two mobiles in is tricky enough. Can you imagine what it's going to be like when it comes to put the whole thing back together? Anyway, so we've got our two mobiles in the frame, and we can put a nut or two on if we want, stop it from dropping apart. Let's just put that incredibly convenient center nut there. In fact, when I reassemble it, don't think there's any point in putting the nuts on it, so we might as well just leave those off. That's doing the job. So everybody loves to see the wheels spinning, but it just kind of is a waste of time. It's nice to do, but it doesn't get you any. If the wheels spin, it's obviously not meaningless, because if they didn't spin at all, then you would be in difficulty. But what you might want to do at this stage, which I would actually want to do, is to do a preliminary cleaning. So just to quickly wash and peg out the bearings, just to get some of this, rid of some of this glue. But because we're on the hoof, here we go. Try not to bang on about it too much. So let's just get this right. Okay, so winds towards the center, so it also runs in that direction. So we've got a force here on this pivot. Poor old tweezers have had a bit of a time, which is pushing the this pinion in this direction, and this one, of course, where you've got an action, you've got a reaction. So that's pushing the great wheel back in this direction. So the great wheel bearing is wearing down here, and this intermediate wheel or second wheel bearing is moving in that direction. And you can see, actually, it's not very worn in the hole, is it? Considering the pivot is, oh, there we are. That's because I pushed it back into its unusual place. So you can see that amount of wear in the pivot hole, but that doesn't mean to say that you need to do bushing, because what we're interested in is depthing, not bushing. Okay, sorry, repeat myself. So the question is the depthing of a transmission of power better or worse with the wheel in its so-called original position? Now, interestingly, people say, oh, you should use the middle of the bush. And this isn't a criticism, it's just what gets passed on from person to person. You can't really do that, and you certainly can't do it here because the bearing is just kind of smudged into the hole. So what we're going to do first is we're going to make sure that that pivot is in its worn position in the plate. There we go. And we're going to try it. I'm sticking my fingers down between the arbors and I'm gently pushing them apart. You can't test the depthing with the wheels spinning freely. They've got to be under load. So what I'm feeling for is smoothness of transmission of power. And the question I'm asking myself, can it be improved? If it can't, I ain't going to do any depth bushing. I don't care whether the pivot's flopping about by 5 millimeters. I'm not going to do it. I've got better things to do. So what you've seen here, look, is that the, just get that around there so you can see it. Come on. Get it at the right height. There we are. Is that the wear, remember we're talking about the meshing of the mobiles here, so the gears meshing together. The wear on this pivot, or the wear on the pivot hole and the pivot obviously is symmetrical all the way around. but the wear on the pivot hole is not away from the center distance. This is the center distance. The wear on the hole, because this wheel's rotating, pushing in this direction, is broadly tangential to the wheel, to the force. So although it looks bad because there's a lot of slop in the pivot, actually, if you try and move the wheel the other way, now moving it in this direction, you can see that there's barely any slop in it because it hasn't worn in that direction. So with the mobiles forced apart, I can feel the transmission of power. It feels all right. It's not perfect. They never are. I'm going to move them together. Is it better? And I can put my hand on my heart and say, no, it's not. It's not perfect, but it's certainly no better. In fact, I would say, if anything, it is fractionally worse. And that's probably because the wheel teeth have also worn and the pinion leaves, the trundles have also worn. Or it might be that the manufacturer was super clever and they anticipated wear, like they maybe did with the escape wheel, and planted the wheels ever so slightly close together so they wore through the optimal center distance. So irrespective of that thing looking wobbly like that, it doesn't need bushing. There's no perceptible improvement to me with them together or apart. And that's it. Rant, not exactly rant over, because I'll continue until I see people stop unnecessarily bushing. And also when you do bush, we'll find one hopefully that needs doing, maybe that escape wheel. Then we're thinking again about depthing. We're not thinking about returning the pivot to its original center distance necessarily, because that center distance we don't know. What we want to do is to return it to an optimal center distance. Right. Okay. So now what I do is take that out, find our, come on, there we go. Yeah, you need to kind of work on 10 of these clocks, or any clock, in fact, to really get the hang of it. So that's that. Right, that's kind of interesting because it's obviously not that one. Right, what I didn't see, they're obviously different, so they're not mixed up, thankfully. So we'll put in our third wheel, which presumably is that one. Don't think it can be that one. I think this is the same wheels. No, totally different height pinion. Pop that third wheel in and just repeat the process all the way up the train. Make a note in your day book of anything. Yeah, if you pull the wheels together and then you push them apart and they are less, the transmission of power feels less smooth in the apart position, then you make a note in your day book and say, yeah, I need to do something about that center distance. And in this case, we've got a double whammy because we've got one pivots and one pivot holes as well. And we can talk about how we deal with that next week. So slightly more successful or less chaotic this week, which I'm very happy about. Now, next week, we are here, God willing. And then the week after, I'm not here. I've got a whole week of contract work, but worry not. It's something that we can all join in with. So that's going to be really good fun. We've got a couple of live streams, say not next week, but the week after. And then it'll be probably Wednesday night. I don't know, but I'll let you know next week what the situation is with that. But don't worry, we can continue being horological. So we're up for time. Let's just do this one. So here we are. We look at our pivot holes. And again, look there. Obviously, we've got the same wear. We just saw that a minute ago. That's going in that direction, wasn't it? That winds towards the center. So that's been forced that way. Okay, so that's going like that. Just to get them going. There's no point doing it in the wrong direction of rotation. So get my two finger and thumb, there they are. Push the mobiles apart like that. Actually, again, really smooth. Now I'm going to push them together. Slightly less smooth. So I think what's happened here is that the teeth and the trundles have just worn themselves smooth. They've changed. If you look at the teeth, they're kind of scalloped a little bit. So again, no bushing required there, irrespective of whether that pivot looks like it's flopping about or not. So there we go. Thank you very much. What I'll do before next week, it's going to be increasingly busy as we get further out of lockdown, but I'll try and do that preliminary cleaning so it's not all covered in yuck. And I'll continue and very, very quickly go through all the depthing, but there's no point repeating it. And if I find one where the depthing needs improving or could be improved, then we'll do some bushing. Otherwise, we'll probably look at the escapement. And then we've got those ratchet clicks to look at as well and figure out how on earth we're going to make those better. And maybe Jonas is going to spring into action with one of his amazing videos and make that a little tool for extracting the arbor from the spring. Anyway, take a breath. Thank you very much for joining us. Really great to see you all. And again, Derek, thank you for popping along for the last 10 minutes, considering you've no doubt had a pretty tough day. And thank you to Team Open Clock Club for rushing home from work and doing the live chat. So we look forward to seeing you on Saturday, all being well, at our Open Clock Club. And in the meantime, as always, much appreciated your support on our Facebook page, which has now gone over 1,100 members. And it's great when you've got a clock in bits. If you can, please just take a few minutes, take some photos, stick them on the Facebook group and just share with us, because that information is gold dust to beginners, even if you know the thing inside out. So there we go. I'll do some photos with my other camera here. And yeah, all been well. See you Saturday. If not, have a great weekend and we'll see you same time next week. Thanks very much and bye for now.